Your mic's
A
breaking up.
little bit choppy, Abby, but thanks for that.
Yeah,
So,
we
if you
think
want
we
to,
know what you meant.
we got you. Abby's taken over from Latch. Really pleased to have her on board. Great team at Space Store. Ayla in the back office as well, handling a lot of the production work for us. Really, really good team. I always give a big shout out to Space Store at the end, but it's just really nice to have such a passionate, enthusiastic team with us all the time. So thanks for the intro. We have got a cracker today. We've got some cracking stories as ever. Terry's always got the best stories. But we're going to start off with a little bit of sad news. A little bit of sad news that annoyed Terry and I to some degree because it didn't really get a mention in the mainstream news. Why, we still don't know. So the Apollo astronauts, obviously we're coming up on the 50th anniversary of the final Apollo mission, Apollo 17, which was 50 years ago this December. And this kind of links in with this story as well. So there's only 24 people so far who've been to the moon. Some of them have done it multiple times, Gene Cernan being one of them, John Young being another, on various Apollo missions. But only 24 in total have been to the moon into lunar orbit. Obviously, that's hopefully all going to change with Artemis and what's coming up in the not too distant future. If that thing ever gets off the ground, we shall see. But one of the key people behind this, and probably again one of the great unsung heroes of the Apollo era, is Jim McDivitt. Now, for those of you who don't know Jim McDivitt, Jim was selected in astronaut group 2, so one of the earliest astronaut groups. Obviously, group 1, you had the famous Mercury 7, Deke Slayton and Gus Grissom, all of the other crew there. Group 2 included people like Neil Armstrong, so this was a really important group in terms of what happened during the Apollo program. Now, Jim McDivitt, really obviously hugely experienced test pilot as they all were, thousands of hours of flight experience, etc. Came in on group 2 and was pretty much assigned to be commander of a mission very, very early on in the Gemini program. So Gemini, as they call it in the US, Gemini as we tend to call it over here, in Gemini 4. Now, Gemini 4 was a really seminal mission for 2 reasons. One, it was one of the first attempts that NASA have made in terms of on-orbit docking with another spacecraft, the spacecraft in question being the Titan that had launched them. So don't forget, in the early days with the Mercury, Redstone, etc., these were ballistic missile launches. Basically, they would take the missile off the top of the spacecraft and stick an astronaut in instead. With the Gemini missions, they put 2 astronauts in instead on the top of basically a Titan ballistic missile. The interesting thing about the Gemini missions and the whole Titan approach was it was the only one that didn't have a launch escape vehicle. So if they had to eject, they literally had to use ejector seats to come out the back. And you really don't want to be pulling like 15 Gs and doing that out the back end of a spacecraft. But essentially, it was not much bigger, as Jim Lovell once said, than 2 phone boxes kind of put together. Really, really tight space. So Gemini 4, 97 hours in orbit. And the interesting thing about Gemini 4, apart from the fact that when they attempted to do the docking, they didn't actually quite make it because they had depth of field perception. So say the pilot who sat alongside Jim McDivitt on that 97-hour mission was Ed White. Now, Ed White was the first American ever to do an EVA. And the original plan for this EVA extravehicular activity was to open the hatch and pop your head out and have a look around. But because Leonov had done an EVA just a few weeks before, basically NASA then decided, well, we're not going to let the Russians kind of take all the glory. And Ed White was then designated to go outside of the spacecraft. Ed White floated around outside, didn't want to come back in. There was there's some great stories. This is what I loved about Jim McDivitt. I met Jim many, many times at Space Fest, been on panels with him. He was such a lovely guy, really jolly, really funny, but very, very serious as well, very serious about his job. He did that with Ed. If they hadn't closed the hatch, there was all sorts of problems with the hatch as well on Gemini missions, where they're wearing pressurized gloves and trying to, get these things closed and get latched over. They had to literally put their hands into the mechanism to do it. Had they not done that, or had anything happened to Ed, Ed would have been basically either cut free and left to drift around in low Earth orbit until he kind of plummeted back to Earth, or they'd have both died on re-entry because there was an issue with the hatch closing. I mean, the whole mission was just plagued with problems, but you don't really ever hear about that unless you talk to people like Jim McDivitt and he tells you all these amazing stories. they obviously made it back safely. There was issues with re-entry as well. With they had to go into like a barrel roll maneuver to do re-entry rather than the standard kind of re-entry kind of descent procedures that all the other Geminis and obviously some of the Mercury's, apart from John Glenn's, had experienced. But the thing, there's some great personal stories with Jim. Jim was one of these people that he'd sit behind a desk at conferences like Space Fest, and he'd be sat typically alongside Dave Scott on his right, and Rusty Schweikart on his left. Now, Dave Scott and Rusty Schweikart came into the story from Jim's later work. So Jim went then on from Gemini, and obviously lost his great friend Ed White. They were at university together, really close friends, and Ed sadly died in the Apollo 1 fire. Jim McDivitt was one of the people, along with Frank Borman, who got involved in kind of restoring the confidence in NASA after the Apollo 1 fire. And Deke Slayton had basically assigned them as backup crew initially onto Apollo 1, and then they got moved, and there was all sorts of crew rotations happening. Essentially, the story is that Jim could have been offered. I'm just going to move my mic. My wonderful background team are saying that there's a bit of noise coming from my mic. He could have been offered the Apollo 8 mission, or he could have been offered more of a kind of view of the moon, as it were. He could have been offered a mission with the lunar module, with the command module. But what he wanted to do was test, and they'd spent years doing this, test the lunar module in orbit. So essentially, Apollo 9, which was Dave Scott, Rusty Schweikart, and Jim McDivitt, it's one of those missions that's so vital to the Apollo program, but is probably the one that's least talked about or least considered of all of them. Apollo 8, obviously the first crew to go to lunar orbit and did the famous, circular orbit around the moon. Apollo 10 went down almost to the lunar surface, just a few tens of kilometers above that, Gene Cernan, John Young, etc. Apollo 11, obviously, the most famous of the missions. But Apollo 9 was vital because they were, for the first time, able to test the lunar module in orbit. Now, the cool thing is they named the spacecraft as well. One of the first times they'd done this. Obviously, with Apollo 10, we had Snoopy, and Snoopy became a mascot for the NASA missions. But they had Spider and Gumdrop, and they nicknamed it Spider because they literally thought the lunar module looked like a spider, and they thought the command module looked like a sweet, like a boiled sweet, like a gumdrop. So that's why they gave them these names. Had that mission failed, again, all of Apollo would have been either like held back, postponed, maybe wouldn't have achieved Kennedy's kind of goal of landing a man on the moon by the end of the decade, as it were. And it was really vital. They had to do the separation, they had to do the redocking. Rusty Schweikart, famous for throwing up for most of the mission, getting extremely space sick, was the first person to kind of be a solo space vehicle in his own right, in that he tested the Apollo EVA suit, the A7L Apollo suit that was used for the lunar surface operations. First person to kind of do that and essentially become a free floating entity, as it were, on Apollo 9. Undocking with a spacecraft that was never designed for re-entry. So if they had any issues with redocking that spacecraft back to the command module, which is the only way that it could get back to the Earth's surface, whoever was in the lunar module was going to die. So it was really, really critical. On the back of that, Jim then basically said, well, that's me, I'm done. I think I've achieved as much as I can for Apollo. And he was basically then put in charge of the Apollo program kind of landing segment of his work, as it were. So again, a hugely vital role, and this is the person, don't forget, oversaw then most of the Apollo missions in terms of surface operations, what they were going to do, procedures, etc. For Apollo 12, 13, obviously 12 almost got cancelled due to being hit by lightning just after takeoff. Almost had to do an abort with Jerry Griffin in charge. 13, everybody knows about Apollo 13. 14, again, one of the unsung missions, with Ed Mitchell, etc., and playing golf on the moon. Apollo 15, his old buddy Dave Scott there, going back to the lunar surface for the first time with a rover, and then up to 16. Now, Jim McDivitt never did 17. He wasn't involved in 17 because he basically resigned by this point. And the reason he resigned is from an interaction with Deke Slayton about another person who I was really close to while he was alive, Gene Cernan. Now, Gene Cernan on Apollo 17 was a really controversial decision to put Gene on that mission. And Jim was vehemently opposed to it. And him and Deke Slayton literally came to blows over what was happening there, because he did not want Gene Cernan on this mission. And the reason he didn't want Gene on the mission, and if you've seen the movie or the amazing documentary on Gene Cernan's life, Last Man on the Moon, you'll know this story anyway. But Gene had a penchant for the ladies, shall we say. And while he was flying a helicopter over the Indian River, the story goes that Gene saw some ladies sunbathing in bikinis, got distracted and crashed the helicopter. And it was a real controversy. It was really bad. It was all over the news, etc. And there were all sorts of, he can't be involved in the mission. But he was, along with Jack Schmitt and, the last people to set foot on the surface of the moon, and did an incredible job, to Gene's credit. Obviously been there with Apollo 10 as well. So he's one of the people, obviously, that went to the moon twice. But Jim McDivitt, it's a real shame, because then at future Space Fest and events and conferences, there was always that bit of tension between them. But seeing Jim, as I said, back with his old buddies, with Dave Scott, Rusty, was really amazing. Always had a smile, always had time to talk to anybody. Would have people in stitches on the panels with some of the stories. I mean, if you ever get a chance to go on YouTube, see some of the panels. Like Francis French, for example, moderated a lot of the Apollo panels at Space Fest. Really, really amazing and funny guy. And it's just annoying that, because Apollo 9 was probably a mission that wasn't as notable as some of the others, it largely gets forgotten. What is now of note, however, is that there's only one remaining full crew left, and that, bizarrely, is Apollo 8, which is one of the earliest missions. So from Apollo 17, there's only one person left. All through 1650, there's very few of the Apollo astronauts left. And I don't know what you think, Terry, but my hope is that some of them will still be there to see the next boots on the ground on the lunar surface, because it would be a tragedy, to my mind. I mean, Charlie Duke's the youngest, and he's in his mid-80s. So I think it'd be a real tragedy if that.
Yeah, I absolutely agree. He did reach a good age. Actually, he was 90, which is reasonably good innings, as they say. The other incident for which he's famous or notorious, of course, was the UFO. The beer can floating around outside the spacecraft. I always wondered why, if these aliens are so incredibly advanced, they can't invent a spacecraft that isn't a bit better than a beer can. I mean, a flying saucer isn't too bad. You could just about imagine that as a reasonable shape for a spacecraft, particularly if you want artificial gravity in it. Instead of the size of a saucer, you make it the size of Star Trek ships, which actually, when you think of it, have their central portion is a bit like a giant saucer. But anyway, if you spin something like that, as in 2001: A Space Odyssey, then you get artificial gravity. Gravity, of course, is one of the things that is totally ignored in all space science fiction movies when they're in spacecraft. But yeah,
not the Martian. No. They did a good job on the Martian.
Yeah, it was a bit better. Yeah, but anyway, the Star Trek, Star Wars, whatever they're in. Yeah. Anyway, will I lead on then to the next topic?
Yeah, just
you finished with Jim.
Just a couple of comments in the chat.
Rest in
peace. But yeah, Chris Parr saying, yeah, absolutely, it was the ultimate test pilot's mission. And hat tips to Jim. He was a great guy. Anyway.
Yeah. Okay, so now to come something completely different. Marshmallows in space, or so the newspaper headlines would put it. The fluffiest or lightest in terms of density planet ever discovered. And as a man who has a great interest in planets from my observing days, this sort of thing always fascinates me. Just a little bit of background. One of the things that amazed me when I first got into astronomy was to learn that Saturn was actually lighter than water in terms of density. So if you got a big enough bathtub, you could put Saturn in it and it would float. Not quite as simple as that. But anyway, Saturn's density is less than that of water. The only planet in our solar system that has that distinction. But what they've now discovered is a planet which is much, much less dense. It rejoices in the name of TOI 3757b. It's orbiting a cool red dwarf star in Auriga at a distance of 580 light years. It's a bit bigger than Jupiter, 150,000 kilometer diameter. Jupiter's about 143,000 kilometers diameter. Very close in, orbiting very quickly around its star. Orbital period of 3.5 days. But the amazing thing is that the density is 0.27 grams per cubic centimeter. And water, of course, is defined as 1. So a little bit of background again, as I said, Saturn is lighter than water, by far the least dense planet in our solar system, with a density of 0.69, or say 0.7. The next lightest is Jupiter at 1.33, and the heaviest actually is Earth with an average density of 5.52. That's quite a considerable range. And of course, the main reason that the gas giants are so low in density is because they're mainly gas. They do have a very solid, dense core, but they have a huge envelope of gas around them. And when you factor that in, then the average density comes in a lot less. And that's probably what we have here. We know absolutely nothing about it, basically, apart from its period. You can tell the size of it by the amount of obscuration when it passes in front of its parent star. You work out the mass from the orbital period and the motion and so on, and that gives you the density. So how on earth can a planet be so low in density, particularly when it is orbiting so close to its parent star, where you would think a lot of the atmosphere might be stripped off? So the obvious guesses are it is a much smaller core than, for example, Jupiter or Saturn, or that there are much fewer or much lower proportion or percentage of the heavy elements in the core, like iron and nickel, and perhaps some radioactive elements and so on, or that has got a very enlarged atmosphere. And again, that sort of is difficult to tie in with the fact that it's orbiting so close to a star, even though it is a red dwarf. Excuse me. So this one's a bit of a mystery. It's fascinating. It's obviously by far breaking the record in terms of the lowest density of any exoplanet known. And hopefully the James Webb Space Telescope will be able to tell us a bit more about it. But if you want to know now sort of an answer for a quiz question, what is the least dense planet known? You may not remember the name, but you can say that is an average density of 0.27 grams per cubic centimeter. So, Nick, what are your thoughts?
It's going to be interesting when the James Webb gets on it, because obviously you're going to get very detailed spectroscopy then, and surface spectroscopy is going to give you a lot more information in terms of what the gas composition is, what it, obviously what it's made up of. I still have serious issues with these close proximity, like supergiants. As you said, they shouldn't exist. They really shouldn't exist, because a star at those kind of orbital distances, it should be stripping the atmosphere away quite happily. You look at Mercury, obviously Venus, you got a very dense atmosphere there, runaway greenhouse effect occurring, etc. And Mercury does have, bizarrely, a very, very, very tenuous thin atmosphere. It's like almost imperceptible, but it is there, as it were. But these enormous gas giants are orbiting, at the kind of distances we're talking for Mercury, Venus, and the Earth, etc. We talk about Jupiter's kind of wacky orbit at the earliest days of the solar system, and the fact that it kind of migrated in. Maybe that's an example of something like this, and we're just catching it at that period in time where it's in a locked orbit with its parent star for a nominal period of time. Obviously, orbital analysis will give us a lot more details in terms of seeing if that is shifting in any way. But if you imagine, early days of the solar system, we now believe that Jupiter was migrating in, and it caused a lot of the issues of the late heavy bombardment 4.5-5 billion years ago. Who knows? Who knows? But it is fascinating. And as you said, the James Webb, that's, you've got to start pointing the James Webb at not only these gas giants, but, looking at the atmospheres of potential Goldilocks kind of zone planets around orbiting stars. 560 light years, we're not going to be going there. Anything within about 80 light years, that's, to my mind, where we should be really hitting the James Webb in terms of looking at gas compositions of planetary systems. But yeah, absolutely fascinating. And I love the fact that it's a fluffy planet. That's great.
Well, we, of course, for what millennia had an example of one in terms of planetary systems, our own solar system. Yep. And if we bothered to think about other solar systems at all, we probably thought ours was fairly typical. We could be absolutely an exception rather than a typical system, because we simply don't know enough. We have discovered a heck of a lot of other exoplanets, but we haven't discovered all of them because of observational selection. The big ones are the easiest to find. The ones that are close into their parent stars are the ones that are easiest to find. There could be a whole lot of other solar systems like ours that they're just not oriented in the right way for us to see them. But it will be really interesting whenever the James Webb starts giving us back a lot more information about these exoplanetary systems.
Well, that's the point. The orbital plane. If you look at the orbital plane of our solar system, if your orbital plane is offset by even as little as 30 or 40 degrees, you're not going to get these transiting events.
Yep.
You're not going to be able to perceive the wobble in the parent star. If the planet itself that's orbiting the parent star is so small that you have an imperceptible wobble again, you're
Yep.
looking at, can you do direct observations? Can you do occultation-based observations? Yes, something like the James Webb is going to give us that capability. The Hubble had that capability, but obviously the James Webb, it takes it a whole factor further. So, yeah, it is. There's so much more out there. There's so much to find about. Anyway, moving on, bit
Yep.
closer to home. Yeah, this is our friends over the water at Darmstadt, Nordwijk, etc. So, European Space Agency, the Hera asteroid mission. So Hera is the follow-on to the DART mission. So the original plan was that ESA were going to launch a spacecraft that was going to go into orbit around the Dimorphos Didymos, orbiting that binary asteroid system that DART successfully smashed into a few weeks ago. Managed to change the orbit of Dimorphos, which is fantastic. And the whole, we can now do planetary protection. It's a little bit of an exaggeration. If we've got decades and the object's small enough, yes, we could nudge it out of its orbit, but let's not get too excited here. If there's something large coming our way, we're dead. But if it's tiny and it's a potential city killer and we've got decades, we might be able to do something about it. It's fine. So, the Hera mission essentially was, ESA had a long-standing relationship with Roscosmos and the Russian Space Agency in the use of Soyuz and Proton rockets. They were going to be used for some of the future Mars missions, some of the follow-on missions involved here. Now, obviously, due to the ongoing situation in Ukraine and the tenuous link that we still got with the ISS is pretty much the last bastion of any space cooperation in the world. And the fact that that's still running, it is hanging on a knife edge most days, as we know with the geopolitical situation in the world at the moment. However, ESA have now taken a decision that, due to the delays that they're still facing, and don't forget, ESA have their own rocket systems. They've got the Vegas, they've got the Arianes, etc. But they were kind of hedging their bets that they would have Ariane 6, which is their kind of new large heavy lift launcher, which was supposed to be coming online pretty soon. That's now been delayed still further. So they're looking at fourth quarter next year, maybe, for the initial launch. And don't forget, with the Ariane and the Vega series, none of these are reusable rockets. So they've got this ongoing issue in terms of cost. You look at the cost of living crisis that everybody's undergoing across the entire world, but Europe's been hit pretty hard, obviously, due to gas restrictions from Russia and what's happening in Germany, etc. The cost of inflation's knocking everything up. So wages are going up, the cost of fuel's going up, all of these materials are going up. And ESA are now looking at a 25% uplift in their, what they call the ministerial budget. So in a few weeks' time, they're going to be hosting kind of a meeting across all of the ESA member states. And they're going to be asking for, I think it's nearly 19 billion extra in terms of budget. Now, it's Chris is saying Ariane 6 is what happens to an Ariane 5 over a weekend away in the Caribbean in the chat. Yeah, it's true.
So just somebody to bring politics in.
Yeah, the thing
I was away for a weekend in the Caribbean.
But this is the problem, is that Elon Musk has redefined the entire space sector so much with the cost savings benefits of the Falcon series, Falcon 9, Falcon Heavy, etc., that lots of agencies now are looking either to ISRO. OneWeb have just gone with Indian Space Agency with their launch. Issues with that, it's the same as Starlink. But SpaceX and ISRO now are pretty much, because you can't launch many payloads from a Chinese launch system, so you haven't got many options left. ISRO being one, as in India, but SpaceX having that reusability. Their cost per kilo to launch to orbit is fractional compared to pretty much anyone else's. India keep their costs low, obviously, because the Indian economy, wages aren't very high, etc. Their overall cost of manufacturing is a lot lower than many Western countries. So ESA have decided to move not only Hera, but several other missions as well to the Falcon series. And it's going to be really interesting moving forward as to the viability of future ESA missions using ESA launches. Now, obviously, you've got member states, you've got investment in Kourou and French Guiana and the launch sites, etc. And, all of the ESA member states put in, the UK puts in billions over N number of year periods to kind of fund scientific endeavours. And there's obviously plans for new lunar rovers, refactoring some of the Mars rovers that we talked about last month or the last show. all of that's happening again in the middle of this cost of living crisis. Now, it brings us on to neatly to the next part in this story, which concerns the UK and the UK's plans for launches. Now, if we go on to the next slide, you can see what the UK's plan is. So, within the next few weeks, we could see the first satellite launch from British soil, as it were. Now, it's not optimal. Let's put it that way. It's not what you would call a traditional launch. What they are using is a US based reconfigured 747 from a US based company in Virgin Orbit, running a US based fueling system that's all been kind of transported over to Cornwall. It's going to be taken off from Cornwall, and it's going to have basically a large rocket under the wing, which the 747 will drop over the Atlantic. And the Maritime and Coast Guard Agency, there's been loads of people involved in this in terms of, granting them authorization, because obviously you've got issues of range safety. With a static launch, if you're just launching vertically, you kind of know your trajectory of the spacecraft. You know what your range trajectory is. If you've got a moving vector, as it were, if you've got a moving aircraft, you've got a lot more problems, because you could say, oh, well, the wind conditions here aren't optimal, or yada, 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 and then you're going to have to move. And if you move by a very small amount, your whole range trajectory and your range safety issues come into play there. So the Maritime Coast Guard Agency, they're still waiting for clearance from the Civil Aviation Authority, who are the people who decide whether or not you can do anything like this from the UK. It's going to have about 9 small satellites on board, really small satellites. We're talking about, largish CubeSats, one of which is going to be the first Welsh satellite, which is really, really cool. But if we move on to the next slide, we kind of go back to what's happening with Cosmigo, and it is very, very interesting as to the cost benefit of this. Now, if you're a small burgeoning space company and you want to launch a couple of small satellites, is it cost beneficial? Because my company had some involvement in the early days of discussions with Virgin Orbit. This thing's got to fly all the way over from California. It's launching out of Cornwall. Cornwall is very soon going to be the only UK launch site, because if Scotland, again, with what's happening with geopolitics at the moment, and in the UK, and if anyone listening around the world, the UK has been a bit of a mess for quite some time now in terms of the political scene. If Scotland devolves and Scotland basically decides to go it alone, then essentially the only launch site from the UK is going to be Cornwall. That is going to be it. And again, they're using a US-based rocket, a US-based launch control system, US-based command and control. So is it really a UK launch? That's the question. I don't know what your thoughts are on this, Terry, but there's a lot of issues in terms of the cost, etc., on this, and what's happening.
Yeah, the only justification I can see for it is that they will reduce the cost of using the base, in effect subsidize the launches. Otherwise, what is the advantage in shipping over everything from America and launching it from here when you could equally launch it from the same 747 at a number of airports in America? I honestly don't understand the logic. Obviously, Branson has sort of a British background. But in terms of the commercial aspect of it, I honestly don't see an awful lot of advantage unless they're getting heavily subsidized, which could well be the case, but I haven't read that.
Well, that's the thing. They're only planning on 2 launches a year, so there's got to be something behind it. And it'd be interesting to almost like a freedom of information request to see what the overall cost benefit ratio is of this. I don't know. Anyway, moving on. Next story, Terry.
Right. Nick, you're still having a fair wee bit of noise on your mic.
Yeah. I'm gonna
move it too far away. We don't hear you, and when it's close, it is a bit sort of noisy on the start of each word.
Just see if I can pop and get.
Okay. Right. This next one then is one of my favorite topics, and this implies that I know something about cosmology, which I really don't. There's a new, ever more accurate measurement of one of the critical factors in the whole question of the expansion of the universe, the rate of expansion, and so on. And it's one of the fundamental problems in cosmology. It relates to the Hubble constant, which is the rate at which the universe is expanding, and by implication and following on from that, how much the acceleration of the expansion of the universe is happening, if it is happening at all. So basically, there are two different ways of coming up with the measure for the Hubble constant, the rate at which the universe is expanding. What was thought to be the most accurate one was the one that measured basically the 3-degree background radiation from the Big Bang. Measured first of all by the COBE satellite, absolutely beautiful follow of all the data points on the theoretical curve, and then to an even higher degree of precision by the Planck satellite. And the people that operate COBE and Planck are absolutely adamant that their measurements are precise and correct. And they give a figure for the expansion of the universe, the Hubble constant, of 67 kilometers per second per megaparsec. So I'll just try and explain that. It means basically that for every megaparsec, and I'll define that in a moment, for every megaparsec that you go away from Earth, the universe expands at 67 kilometers per second faster. And a megaparsec is 3.26 million light years. It's basically a million parsecs. And a parsec is the parallax that a star has, excuse me, due to the orbit of the Earth around the Earth. It's a figure that astronomers use rather than light years. So as you go further out away from the Earth, because the universe is expanding, the further you go, the faster the objects appear to be moving away from you. The usual analogy is, excuse me, we're all having slight problems here. If you put dots on a surface of a balloon and you blow the balloon up, all the dots move away from each other as the balloon expands. So COBE and Planck give a figure of 67 kilometers per second per megaparsec to what they say is a pretty high degree of precision. The other way of measuring the expansion of the universe is to measure the distance to very distant luminous type 1a supernovae. And we think, for various reasons, which I'm not going to go into, that all type 1a supernovae reach approximately the same brightness at their maximum. And if you measure them at ever increasing distances away from the Earth, away out into the universe, you get a measure of how far away they are and how far or fast the universe is expanding in that direction. That comes up with another figure, which is not all that different, but 73 kilometers per second per megaparsec compared with 67. Now, reasonably close, you might think, but the error bars of the two sets of measurements didn't overlap even 10 years ago, and now they've got even further apart because the measures have got more and more precise. And what has happened is that a group calling themselves Pantheon Plus have measured the distances to 1,550 supernovae with an incredibly more accurate degree of more precision. They've also teamed up with another group studying the expansion of the universe called the Howes team, SHOES, and they are now confident that their figure is also very accurate. And as I say, the error bars of the two sets of measurements have now got even further apart, so much so that the discrepancy between the two sets of measurements reaches what they call the 5 sigma level. In other words, there's only about a 1 chance in a million that that's due to chance. It was the level of precision that they needed to confirm that the detection of the Higgs boson was accurate and not some statistical fluke. So the measurements have got ever more accurate, and the two different measurements which should give you the same result are now definitely quite far apart. And this is fundamental to cosmology. I mean, the expansion of the universe is sort of the one thing that everybody takes for granted. It's when you wind the expansion back that you come up with the idea of the Big Bang. If it's not expanding, there's no Big Bang, basically. Well, we're all reasonably sure that it is expanding, but at what rate? And these discrepancies now are what's called the Hubble tension, the tension between the two independent sets of measurements. Both sides are adamant that they're correct, but they can't both be correct. Even if you split the difference and make it around about 70, roughly halfway between 67 and 73, still the error bars of the two sets of measurements don't reach the 70 level. So what is it? What's going on there? Is there something fundamentally wrong with our interpretation of the Big Bang? Was the speed of light different in the early universe? Was there something else different in terms of the density? We were talking earlier, Nick, about the baryonic non-baryonic thing. We're not going to go into all the cosmology, but it really is basically a fundamental problem now in cosmology. And well, that gives the astronomers and the cosmologists that they feed the data to something to keep them in their jobs. So I know you have your own thoughts on this, Nick, but it really is one of the things that basically science has to try and sort out in terms of the physics of the universe. Nick, can't hear you at all now. Right. Nick, I don't know. I'm going to go on a wee bit more while you try and sort out the mic problems. Um, I was talking to one of the guys who was an expert on supernovae at a lecture that he was giving not so long ago, and we addressed this problem. And he said, basically, I'm an observer. I always trust observations over theory, which seemed to imply that he was very much nailing his colours to the mast in terms of the observations of the supernovae. But when you're looking back in time, looking at very different distant supernovae, you are basically assuming that the laws of physics were the same in the past as they are now. We have no reason to believe that they weren't. And when you look at other things like the spectra of very distant objects and so on, the laws of spectra of the way atoms and so on behave in high temperature and density and so on are the same far out in the universe as they are here. Nick, I'm filling in. Have you got your mic on again? No, still can't hear you. I don't know what is going on here. IT problems. I had the same thing with a Zoom meeting not so long ago. So I'm going to again try and fill in while Nick sorts things out there. So if anybody wants to put anything in on the chat, I see we now have some I'm not going to say what it is, but some intrusions there in the chat, so we'll ignore those. Nick, can we hear you now? Nope, still nothing. So I don't know what's going on there. That would really bring us to the roundup, unless you want to come in later, Nick, whenever you see if you can get your the lookup whenever you get your mic sorted out. So how are we for time? Oh, right, I can hear you now.
Woohoo! There you go. How many software engineers does it take to run a microphone?
Off the cuff, flanneling away there about supernovae.
No, I was listening to it. It was bizarre because I was listening to you on the phone while I was sorting out the microphones, trying to keep obviously up to. It is really interesting. The whole, as you said, I've got my own ideas in terms of baryonic and non-baryonic states, and there was we were saying just before we came on air, there was a really interesting article in one of the UK's main broadsheet newspapers from a notable astronomer who finds it really difficult to argue what he believes the fact that dark matter, dark energy are just fictional constructs to try and kludge the various things that we can't understand into some form of normalcy. And as Terry said, the speed of light. Oh, was it faster at the early part? Hold on. Things like this is fundamental laws of physics: the creation of matter, the creation of energy, the speed of light. These are all fundamental to our understanding of the universe. And if you're saying you've got to fudge it at the earliest epochs of the universe, you've got to basically break all the laws of physics to make the universe actually sit together. To my mind, it's Occam's razor. It's a time to rethink what we're doing, because essentially what we're doing again, and we did this 500-600 years ago when we thought that the Earth was the center of the universe, and it's like, oh, there's this planet called Mars, and it seems to be doing this weird retrograde orbit thing. What's going on there? And yeah, we're doing it again, but we're doing it with more advanced thinking, more advanced technology, more advanced understanding, but we're still essentially making the same mistakes. We're fudging things again and again and again, just kind of just to make sure that the universe is doing what we'd like it to be doing. I don't know. It's very weird. It's interesting as well. It's a great sign that we're getting all this spam in the chat, by the way, because it means that we're popular. I'm on various other chat forums.
Not those ones, I hope.
Not those ones. No, music technology related ones, because I'm really into music technology as well. And it's really interesting. They get bombarded occasionally with spam as well. So it's a nice sign that we're obviously hitting a wider demographic now. And the lonely ladies, as we call them, dating sites, ignore that. It's just spam. It's what happens. Everyone's been getting on their mobile phones in droves, I'd imagine, of late, with energy crisis and what's happening. So, but it's really nice to know that we're not oblivious to it in our little nerdy show on space. Right.
So what's your money? What's your money on the Planck Kobe data or the supernovae data?
The problem is, you look at the Planck Kobe survey, and it was, if that's wrong, that's an awful lot of careers at the Swanee.
Yeah.
That's the problem. I mean, a lot of people, as the guy in the Guardian article said, there's a lot of people whose entire careers have been based upon observational data that could fundamentally be flawed. And this is the problem with astronomy, it's science by proxy. We can't go right now. We can't go to an exoplanet to see if it is actually that mass. If it does have that atmosphere, if it does, we're observing it from a distance. And it's the same with anything. Our understanding, up until the 1950s, we thought that there was life on Venus. Notable astronomers, really notable astronomers, thought that potentially could be life on Venus. Patrick Moore, our great friend Terry, was a big believer in like volcanoes on the moon and the cratering. The thing is, our understanding of science is always moving forwards. And as it moves forwards, we need to be big enough and brave enough to say we got it wrong. That's fundamentally what needs to happen here, rather than saying, well, I'm right, and blah, 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 I'm an eminent professor. Some of the greatest discoveries, there was a really good one with the discovery of Richard III, completely off topic here, but Richard III, famous king, and an amateur historian basically had a theory that he was buried under a car park in Leicester. And she went to this car park, saw an R on the ground, and all that meant was reserved space, but she had a gut feeling that that's where he was. So it was like, okay, let's put a trench in there and dig. And all the archaeologists and the scientists at Leicester University were all mocking her and thought, she was completely crazy. She was right. And I'm not saying that, the average amateur is right, but Einstein was a patent clerk, as we all know. He came up with general and special relativity. There's been some notable discoveries in science all through history that are very serendipitous. You look at William Herschel, he was a fantastic mirror maker, but he was a musician. He was essentially hired to be an organist in Bath, and was really good at making mirrors, discovered a planet. So, and, Caroline, his sister, cometary discoveries just off the scale. So you've got to take that into account, and you can't always think, well, because we're fantastic scientists and we've spent billions of dollars or whatever on our research, that we're right. Because sometimes we get it wrong. We've just got to be brave enough and big enough to admit it.
Yeah, fair play to Patrick. He did admit, when the evidence was strong enough, that basically the craters on the moon were due to impact and not to volcanism. So, okay, we're back on schedule again. I think, have we time? Anything else you want to cover before we do the lookup?
I think we're good. Let's do lookup.
Okay, fair enough. Right, a couple of things coming up. The Taurid meteors. Not one of the greatest showers of each year, but there's something special maybe in store for us this year. There are two branches to this set of meteor showers. They come from Comet Encke, which is the comet with the shortest known period, about 3.3 years. There's the southern group, which peak on November the 5th, and the radiant of that is a bit to the right and below Aldebaran and the Hyades. In fact, it more or less is an equilateral triangle below and like to the right of Aldebaran and the Hyades and the Pleiades. The trouble with that is that the moon will be nearly full when they're at their peak. The second branch of the Taurids, called the Northern Taurids, peak about a week later on November the 12th. And that radiant, as the name implies, is a bit further north between the Pleiades and Aldebaran. And this time the moon is just past full. So that's not ideal conditions for observing a meteor shower. particularly when it's not a particularly rich one, between 5 and 10 per hour. The thing is that there seems to be a reasonably good chance that we'll get some fireballs this year. The torrids always are relatively slow, long paths, so they're relatively easy to see. Meteors that are very, very quick, sometimes they flash past in the edge of your field of view, and you hardly can see them at all, but you saw something. But the torrids tend to be slower with long paths. And every 7 years or so, according to the American Meteor Organization, they seem to produce an exceptional number of fireballs. In other words, meteors that are a lot brighter than usual. And the 7 year cycle comes around again this year. So there is a chance that, in spite of the moon, you'll be able to see a reasonable number of the torrid meteors, because fireballs you can see even with bright moonlight because they're a lot brighter. And because they're long and slow, they're really quite spectacular. You can follow one across the sky. For some of the very fast meteors, as I say, they just flash and they're gone. But if you spot one of these ones, you can see it and turn your head or turn your eyes and follow it to the end of the path. And that's really something quite special. So look up on those two dates, the 5th of November and the 12th of November. As I say, the moon isn't quite full. It's just coming up to full and just past full on those dates. So it's not too bad, and it's definitely worth having a look. And when you're looking later in the night, you will notice, first of all, that Jupiter is still there, by far the brightest object in the night sky, apart from the moon. But you'll be certain to notice Mars coming up in the east, really bright now and noticeably red. It's much, much brighter than any other red star in the sky, like Betelgeuse or Antares or Aldebaran. It's coming up to a very good opposition in December. So there's two things to watch. First of all, just as it brightens, it will never get quite as bright as Jupiter, but it will get brighter than any other star in the sky, about twice as bright as Sirius. Notice the beautiful red color, and also notice that the orbit is retrograding. Not quite yet, but over the next week or so, you will start to notice that Mars appears to move backwards relative to the stars.
Which goes back to that thing we were just talking about.
Yeah, exactly. How do you explain that if the Earth is not the center of the solar system? So that's very easy to see. Mars is the planet that shows the most retrograde in its orbit. And it's very simple. It's simply that the Earth is orbiting faster, and it catches up on Mars as they both go round the sun, a bit like a runner on the inside track of a racetrack passing a runner on the outside track, not necessarily traveling any faster, although it is because it's closer to the sun, but it's also moving basically in a shorter orbit. So the Earth appears to overtake Mars, and as that happens, Mars appears to move backwards relative to the stars. Of course, if you're observing it from the sun, it would be continuing to move around in the normal manner. So look for that. And the other thing we wanted to cover was the partial eclipse of the sun that occurred this morning. It was visible, in theory, if the sky was clear, all over the UK. I managed to get some reasonable glimpses of it through partial cloud when I was down in Dublin. I've seen quite a few photographs from some of my colleagues. So just to get a bit of feedback from people, who else saw it? Who else managed to get some photos of it? What about you, Nick? Any luck?
Sadly, no. I was watching a tree being felled.
Oh, yes, you mentioned, yeah.
Gigantic tree. No, it was very cloudy, but I did see some of the pictures, again, from all over the country. The really good ones, there's some really good, obviously you've got to use specialized equipment, you've got to use filtered telescopes, never look at the sun, obviously. If anyone's watching and listening, never ever look at the sun without the correct equipment and filters. I saw some really good ones that showed when you're looking at the limb of the moon and you can see the mountains.
Yep.
And this is really noticeable with things like total eclipses, and you see the Bailey's beads, and even annular eclipses when you can see, some of the mountain ridges around the edge of the moon, of the lunar surface. It's amazing. It really gives you a sense of just what it is we're looking at here. Going back to the Taurids, the interesting one with it being Comet 2P Encke. If people don't know, what's one of the things that they believe may have caused the Tunguska fireball event in 1908 was that potentially if a fragment had fallen off Comet Encke, and it's not a particularly great meteor shower, as Terry said, but it could have caused one of the most catastrophic impact events in modern times. 1908, Tunguska got hit hundreds of square kilometers of forest, and lots of reindeer got killed and what have you. And one of the theories that it was part of Comet Enki in an airburst. So it's worth keeping an eye out for. It's one of the better ones in that, as Terry said, the moon isn't going to be quite as bright. It's not quite as good as the Perseids in terms of, it's not height of summer and you're not as warm. But as it starts to get a lot colder through like winter months, December, January, February, looking out for meteor showers, unless you're really into this stuff, can be a bit tricky. So it's probably one of the last good ones for anyone who's got a casual interest to kind of sit in the back garden, grab a cup of hot chocolate or whatever, and just enjoy. So definitely, and Mars, if you've not seen Mars through a telescope, if you can get to a local astronomy society, if you've got access to a telescope, have a look at Mars, because again, being able to see surface features on a planet, with a really good sized telescope, you can see things like Olympus Mons, for example, which is the largest volcano in the solar system. Being able to see a volcano on the surface of another planet is quite something else. And you can definitely see the ice caps, and you can see some of the larger kind of features, as it were, that, bless him, just over 100 years ago, Percival Lowell and various other people thought were evidence of life and canals. So it goes again back to our, we need to move forward with our understanding, because 100 years ago, we thought there was intelligent life on Mars and there was canals there, and H.G. Wells wrote about it and yada yada. So Chris in the chat, absolutely right, Chris. What we know is always wrong. It's just a matter of by how much. So on that note, I'll hand back to Abby.
Well, I was just going to say, we have a bit of time to spare. What about Artemis? What do you think of that? What's the latest on that?
Artemis at the moment, obviously Boeing. I mean, I've got major issues with Boeing and their quality control. Who knows when that thing's going to launch? We've got to get it off the ground, but again, it goes back to the argument I was talking about with the European Space Agency. If you've got a reusable system, and SpaceX have, if Starship eventually goes off, as it should, and you've got full reusability on something that is literally the size of a Saturn V, and you can bring it back down and reuse 90% of the entire spacecraft, obviously fuel aside, etc. The argument for having the Artemis program moving forward, especially with the launch costs and the given, the current cost of living crisis all over the world, are the general public going to swallow it? Yes, it's exciting. It's fantastic to see. I've been pestering for years for us to go back to the moon. But given the current economic climate, etc., and yes, we need to do science, but we can do science in different ways. And SpaceX, for all of their failings and for all of Elon Musk's failings, both as an individual and what he's doing with Starlink, etc. We talked about this so many times, but he's got something, that is way ahead of anyone else. And Artemis at $3 to $4 billion per launch, actually, it's not going to fly with the general public. It doesn't matter who you put on the set, and it's going to be exciting. The first return to the moon, for anyone who's young enough to have missed it, myself included, just about. It's going to be really exciting. First female on the moon. It's going to be brilliant to have a wider representation of humanity visiting another world rather than just a bunch of test pilots. I don't know. It's I'd like to see it take off soon, but I have very, very mixed feelings about the whole program.
But they can't abandon it now unless it blows up on launch. They'll have to go ahead with it.
Yeah, this is the thing, and if it blew up on launch, then Boeing, I think, would. Yeah, but then they're talking about Boeing and Northrop Grumman getting all the contracts. So who knows? Anyway,
right.
Back to Abby.
Look, sorry. We had a slightly shorter program than usual there because Nick lost his mic. I have to say, just that mic is excellent. Yeah, there were always problems with the previous one, so if you're using that in future, it should be all right.
This one was given to me by the BBC.
Right. Okay. So we'll finish now a little bit early for a change. So back to you.
Great. Okay, can you hear me this time?
Yeah, we got you.
Okay, don't know what happened at the start. Sorry, everyone. I'm Abby. I'm taking over the Space Store end of things. But other than that, it's all remaining unaltered, so don't worry. Just a quick note from Space Store. We've got some new meteorites in both the Didcot and the Oxford store. So if you want to get your hands on a piece of meteorite, we've got lunar meteorites and Martian meteorites as well. Come down to the store and see what you can find. And we'll be back with Space News Roundup. Do you guys know when we're back?
Yeah, 2-3 weeks time. Yeah,
2 weeks now. So we'll be back in 2 weeks, and we'll see you all then. Thank you for spending the evening with us, and thank you, Nick and Terry, for that great show. Really enjoyed it.
Brilliant. And back to, on the meteorite front, just to say, if you don't know, the people who were one of the people supplying Space Store with the meteorites is none other than Steve Arnold, one of the world's most famous meteorite hunters from the TV show Meteorite Men. So they're lunar and Martian meteorites coming directly from literally one of the world's most famous meteorite hunters. So
absolutely, go check out the check out the show definitely if you want to come in and see them.
Okay, cheers
Great.
everybody.
Bye.
See you next time.
Cheers.
Bye.
Bye. Bye. There's only been about 20 or so recorded falls in British history. So to get one at all is quite rare. To get one that's witnessed is incredibly rare, and then recovered, I mean, this is off the scale rare. It makes it even more interesting in that the meteorite is what's called a carbonaceous chondrite. So these are some of the most primitive materials in the entire universe.